Okay, so this is a question that appears in the plug-in chapter of the Pwn the SAT Math Guide. And in the explanation for this question, I say you'd have to be an evil genius to want to solve this without plug-in, to solve it generally. So of course, a few aspiring evil geniuses email me once in a while asking, what is the general solution? How would you do this without plugging in? And so I figured I'd make this video to explain that. But first, let's talk through the plugin. Let's talk about how this works in one case, and that will help us to see how it's going to work in every case. So the first thing you need to know is that if you want to find an m, right, so m is divided by 6 gives you a remainder of 4. If you want to find an m, the easiest way to go is just to say, well, 6, right, because 6 divided by 6 gives a remainder of 0. So 6 plus 4, 10, that gives us a remainder of 4 when divided by 6, right? 10 divided by 6 is 1, remainder 4. So we're going to say 10 is m. And then we're going to do the same thing for m. We're going to say 6 plus 5, which is 11. When 11 is divided by 6, it gives us a remainder of 5. So n is 11. So that's the easiest way to find an m and n. And now the important thing is that that would work if we said 64 and 65, or 604 and 605. Anything that's a multiple of 6 plus 4 is going to work for m. And anything that's any multiple of 6 plus 5 will work for n. But to keep our numbers easy, we're going to use 10 and 11. So mn is going to be 10 times 11, which is 110. And now we're going to do some old school long division to find the remainder when 110 is divided by 6. So 6 goes into 11 one time. 1 times 6 is 6. 11 minus 6 is 5. So then 6 goes into 50 8 times, right? And then 8 times 6 is 48. 50 minus 48 is 2. So my remainder is 2. Cool, right? So our answer is 2. Now, how would we solve that generally? Well, remember what we said about 6 plus 4 equals 10. The easiest way to find an m is to take a multiple of 6 and add 4. So our general solution is going to have to be for all multiples of 6 plus 4 and all multiples of 6 plus 5. So here's how we're going to do that. I'm just going to clear all this out. Control Z. All right. Now, let's say there's an integer a and there's an integer b, right? A and b are integers. And so now for m, I'm going to say m is going to be 6a plus 4, right? So that's any integer a will be a multiple of 6. 6a will be a multiple of 6. So plus 4 is going to give us a multiple of 6 plus 4. So that's going to be m. And n is going to be 6b, so a different integer, or it could be the same integer, but whatever. So some multiple of 6 plus 5. And so now, to find mn, we're going to have to do a little foiling. 6a plus 4 times 6b plus 5. And so that's going to be mn, and we're going to FOIL it. We're going to say mn equals first 36ab, outer 30a, inner 24b, and last 4 times 5 is 20. Okay, look what we've got here. 36ab, well, if 36 is a multiple of 6, which it is, then 36ab will still be a multiple of 6. So a multiple of 6. 30a, 30 is a multiple of 6, so 30a is a multiple of 6. 24b, 24 is a multiple of 6, so 24b is a multiple of 6. 20 is not a multiple of 6. But what is a multiple of 6? 18 is, right? So what if I said that mn, I'm just going to write it in a different and cleverer way. I'm going to say mn is 36ab plus 30a plus 24b plus 18 plus 2. And now I've got multiple of 6, multiple of 6, multiple of 6, multiple of 6, and then 2 left over. So just like we knew before that any multiple of 6 plus 4 gives us a remainder of 4 when we divide it by 6, any multiple of 6 plus 2 will give us a remainder of 2 when divided by 6. So if I divide this by 6, no matter what a and b are, as long as they're integers, I'm going to get a remainder of 2. And that is your general solution, evil geniuses. Go forth, wreak havoc.